Hello friends, this is Gangadhar with another video from geometry. In this video, I am going to discuss about axioms of geometry. Basically, what is an axiom? Axioms are the geometrical facts. And what is a fact? See, axioms are the geometrical facts, and the facts in generally, facts means the statements or the observations which are eternally true. Eternally true in the sense, the observations are the statements which are true irrespective of time and irrespective of place. Okay, since they are irrespective of time and irrespective of place, they are true for a long period, for every time and at any place. So they require no proof, and just we conclude those facts by an observation. For an example, see, sun rises in the east is an axiom. Sun rises in the east is an eternal truth. It's a fact which requires no proof. If you try to conclude, just you have to observe it. So it requires no proof. Such type of statements which requires no proof and which are eternally true are called the facts. In the same way, like sun rises in the east, there are certain statements, certain observations in the geometry which are eternally true. Those statements are called as the axioms. Usually, axioms are the fundamental observations for every theory. Based on those axioms, based on those initial observations, we can develop the complete theory and we can use it in regular life. Right? Now, here the axioms are the geometrical facts. So, these axioms requires no proof and just we conclude those by the clear observation. Right. See, these axioms here in the geometry are given by the father of geometry, Euclid, and the initial axioms of this geometry are called as Euclid's fundamental axioms. There are certain fundamental axioms initially, and in different parts of geometry we will observe different axioms, and then we will develop different theories and the theorems based on those axioms. With the help of those theorems, and then we can solve different problems, right? So initially, Euclid's fundamental axioms. The first fundamental axiom is the, take a line. As we discussed, for a line there exists infinite number of points. See, as we discussed, a line is an extension of line segment endlessly in two directions. See, if you consider a line which is extending indefinitely in both the directions, there exists infinite number of points on this line. This is the initial observation. The observation is very clear, but we are mentioning it as axiom 1. What it is? There exists infinite number of points on a single line. And the second axiom is, if you have a point on a plane, through this point there exists infinite number of lines. There exists infinite number of lines passing through a given point of the plane. See, there exists infinite number of lines. This is another axiom. Axiom 1 and axiom 2. Axiom 1 is, there exists infinite number of points on a line. Clearly it requires no proof. Axiom 2 is, there exists infinite number of lines passing through one given point on a plane. It also requires no proof. These two statements are very obviously clear, so we consider these two as the fundamental axioms. And then coming to axiom 3. Axiom 3 is just, if you have any 2 points on a plane, this, as we discussed, this board is a part of the plane. On this board, if you take any 2 points, name them as some P and Q, passing through these 2 points, there is one and only one line. There exists only one line passing through 2 given points of a plane. We are not able to draw another line which is passing through these 2 points. Okay, this is axiom 3. Axiom 3 is that there exists only one line passing through 2 given points on a plane. This is also very clear. And then coming to axiom 4. Axiom 4 is about 2 lines. If we take any 2 lines on a plane, see, if you take any 2 lines on a plane, these 2 lines may have one intersection point. If you take any 2 lines on a plane, these 2 lines may not have any common point. That in the sense, if you take any 2 lines on a plane, those 2 lines sometimes have one common point, sometimes have no common point, and More than that, we don't have any other possibility. So axiom 4 concludes that there exists at most one common point for two different lines of a plane. So axiom 3 is there exists only one line passing through 2 points. Axiom 4 is there exists at most one common point for two lines of a plane. These are the basic four fundamental axioms. See, these axioms, we can observe these axioms with a paper along with a crease. For example, I have a paper. See, this is a paper. If you consider this paper as a plane, and if you fold this paper to form a crease like this, so anywhere, somewhere if you fold like this, and after opening this is a plane, and this creasing of the paper looks like a line of the plane. Plane extends indefinitely in four directions, as well as line also extends indefinitely. So this crease usually considered as line of this plane. Right? So now I am going to discuss axiom 3 with the paper. For example, I have a plane. This paper is nothing but a plane. See, plane having two fixed points on this line. See, try to fold this paper along these 2 points to make a crease. So I am trying to fold this paper just along these 2 points. Okay. If we try to fold this paper along these 2 points to make a crease, and that crease is nothing but a line, so this is the line which is passing through two given points of a plane. And if you try to make another crease which is passing through these 2 points on this paper by folding, it is not possible. We can't make another crease. Just it is possible to make only one crease like this to make a line. So it concludes that there exists only one line passing through two given points of a plane. This is axiom 3, what we discussed, right? And then coming to axiom 4, for example, axiom 4 is nothing but there exists at most one common point for two lines of a plane. See, this is a crease, that in the sense one line, and if I make another crease like this crease corresponding to the folding is one line. This crease corresponding to the folding is another line. So if you observe, there exist two creases, acts like two lines of a plane. These two creases are intersecting at only one point. That is the intersection point actually. So it concludes that there is only one common point for two lines. We don't have any other common point for these two creases. So that in the sense, there exists at most one common point for two lines of a plane. Just to understand, to observe axiom 3 and axiom 4, I used papers like this. Okay. So these are the basic four fundamental Euclid's axioms. Okay. And so in some cases, in some books and somewhere, axioms are also called as postulates. Actually, axioms and postulates both are same. Postulates are nothing but initial theories, initial statements, observations which are used to develop complete theory are called as postulates. So we may call this as Euclid's postulates or as well as Euclid's axioms. These are the four fundamental axioms, and along with these four axioms we have another axiom which is called as parallel lines axiom. Parallel lines axiom. Okay, see what is this parallel lines axiom? So the name itself is containing two parallel lines. If you have any two parallel lines and if you try to observe the distance between these two parallel lines, at anywhere the distance between these two lines is always constant. The distance between two parallel lines is always constant. Usually we consider the railway track as the example for the parallel lines. The distance between the two tracks of the railway line is always fixed. Okay, so this is the parallel lines axiom. The distance between two parallel lines is always constant, is the parallel lines axiom. So in this session we discussed about the five fundamental axioms. Okay, right. So in the previous videos we discussed about the defined terms and then undefined terms in the second video. So geometry is basically a language, and to understand, to analyze and to solve problems of that language, initially we need to know the terminology of the language along with the initial observations. So in the last two videos I discussed about the basic terms of geometry. In this video we are discussing about the initial observations, nothing but axioms of the geometry. And the next video, we are going to solve different problems, simple problems related to these axioms and with their terms, which are useful for different competitive examinations, right? So don't forget to subscribe and share the video. Thank you.